Hello, my name is Michał and I'm working in Intel, as you may have noticed. We're doing OpenStack out there. I personally use cloud. I mean, I swim in clouds in several ways because I'm also a pilot. So, and today I'm not going to tell you about OpenStack. I think you have heard enough of that. So, although I will bring you bad news, but please don't kill the messenger. And bad news I'm going to talk about is that things breaks. Everything breaks. No matter how much money you were spent on hardware, no matter how expensive that was, it will break eventually. It's not the matter of if, it's matter of when, and it's matter if you will be able to replace it before that occur. You not always will. Sometimes something just will cut the power, or someone will tip over the cable, or the disk will blow up. This thing happens. So Chaos Monkey. What is Chaos Monkey? Chaos Monkey is a little script which you can find here. It's a Netflix thing. Netflix is based on Amazon. Amazon, if you will read their agreement, they don't give you any SLA. If your VM dies, it dies. We don't care about that. You have to care about your own VMs, and you have to care about how to make your applications in the way so if the one VM dies or one region dies, and it has happened on several collisions already actually, how to write the applications so it will survive the crash of whole region, for example. So the Chaos Monkey is a script which is nightmare of everyone. I mean, it seems as a nightmare because it's script that runs over your production infrastructure, and I will stress that it's production infrastructure, and it breaks things. It breaks everything. It shuts down the VM. It projects latency on network. It kills the connections. It breaks everything they can think of. And because of that, they ensure that whatever they do, it's fault tolerant because it's broken by design. And as I said, there were several occasions when whole region of Amazon died, and Netflix was one of the companies that actually survived the crash of entire region, and that was pretty amazing because not many companies did that. So let's talk about how to achieve that kind of high availability. For start, let's talk about a few basic concepts: quorum, cluster, statelessness, and maintenance. Let's start with quorum. Quorum is I'd say it's way of thinking, because it's basically it's thinking that you have to have at least two of everything. Two servers which are connected to two different network connections, to two different switches, which are then connected to two different network providers, and they are interconnected. And so in any single point dies, the other can take its job and do it. And best case is if those two are the farthest away from each other as possible, even different continent, different data center. The farthest they are, the more they can endure, because whole data centers can die. Cluster is basically it's a way of making those things to work. I mean, if you just put two things, they don't like to be interconnected. They aren't like to work with each other, and that's what cluster is about. Clustering software makes things work with each other, and I will speak about that mostly here, and that's a the question. I don't know if you know that. The main cluster, the main like design pattern for cluster, the most basic one is active passive, and in Django it's actually covered by master-slave database. I don't know if you have seen that pull request, but it's basically political correctness at its finest, because they in this pull request they change every occurrence of master-slave into because they consider master-slave as racist, so they change it to, I think, leader and follower or something like that. But go there, read the comments. It's priceless. So yeah, that was the aggression. Okay, so let's go to statelessness. When you think of, for example, HTTP, I mean, HTTP is stateless, I'll say that in a moment, but you click, you go somewhere, and it's like one action leads to another. That's not a good pattern, actually, because if something breaks in the middle of this action, you can't recreate it, because there are steps that needs to be done before. So statelessness is actually that you can take the state. I mean, you can make request, get a response, and all the information needed for the proper response is in the request. So if one request timeouts or something, you can just make another request with the same payload, and it will do just the same. Okay, having said that, let's talk about quorum, quorum again, because I lied a little bit that 2 of everything is good. Actually, it's free. Why it's free? Because there's third one, maintenance. So we have a server. Server has a software. Software, for example, Linux kernel, something like that. We'd like to upgrade the kernel. It's hard. I mean, it is technically possible to upgrade the kernel on the running service, but it's hard, and personally, I'd rather not do that on production. So maintenance mode is that we purposely turn off one server out of the cluster just to perform upgrades, and then we still have the 2 remaining, the HA. There's still we still have 2 servers working, and one of them still can break. Of course, there are some. You have to make sure that you won't end up, you won't end up, this one won't lack on performance, but that's another thing. You have to actually have at least 2 of everything, including performance-wise. You have to have at least twice more performance that you actually need at all times. So, as I said, the first design pattern of HA is active passive, which is easiest, unless it's not. Active passive, in general, looks like that. We have master slave. Sorry, I'm not politically correct here. I will use master-slave nomenclature, so because yeah, I'm just evil guy. So we have master-slave, master and slave. Pretty much most of the time, master does all the work needed. It runs your applications here, and it does all the work. But there is hot standby, a slave which is waiting. If it for a moment when it's needed, when master dies, for example, like here, the slave will take off the job for master, and we still have our downtime. We still won't have downtime because slave can perform just as well in general. But how can we make that? How can we make that work? Well, the simplest thing is to use floating IP. So we live in networked world. Everything is interconnected by networks. So we may just move the IP from from master to slave, and just DNS sees that 555 is our website, but as it happens, 555 suddenly points to different server when, for example, master dies. So we migrate 555 to slave, and then slave takes all the traffic by itself. As you can see here, there are several actually possible software that can do that. It's Keep Alive. Keep Alive is the simplest. Pacemaker is a bit more complex. Basically, Pacemaker will do a lot more, and it will do quite fast unless it's big, because Pacemaker, if you have more than 10 nodes, I would be cautious using Pacemaker. Keep Alive is much more lightweight. Still, that's two pieces that does that thing. There are a few others examples of AP. I mean, somewhat active passive cases, because DB replication is not actually fully active passive, because the replica or the slave actually takes you can make selects over it, but inserts go to master node. Although there are some cases when you can scale that out. I'm not really a database guy. I won't give you exact hints how to do that, but it's possible. DRBD, on the other hand, is quite nice tool if you know how to use it. It's just, let's say that your master node writes to a file, and this file has to be shared because it's, I don't know, some file, and you don't want to make shared storage because, I don't know, it's hard, something. DRBD is basically the daemon that keeps the states of two files the same content. It synchronizes the content over network, onto servers. But I mean, it doesn't scale very well, so be careful about that. Okay. So why do we actually want active passive? Because it seems easy. I mean, you just write the code and you copy it, and it does the job. You have a get HA. But in reality, it's not. It's not that simple. I mean, if you have been in yesterday's talk of Pygmy, you might have seen that the replication is hard, especially if you're talking about data. So what's the actual problems of active passive approach? It doesn't scale very well. I mean, it doesn't scale at all, pretty much, because you have one master and there's only one server that do the job. So every server has limited resources, and they will end eventually. I may digress here. I mean, I will tell one thing about OpenStack, because there are a few cases when OpenStack has this problem. We are working on it, but that's the main. I mean, not main reason about active passive. Why we don't have active passive, but that's our very very important one. But there is something. I will argue that something far worse. The split brain. What's split brain? So imagine that we have two nodes. One is master, one is slave, and they are interconnected by network. So master connects to slave, yeah, still works. So okay, but I don't really care because I'm master. and the slave connects to master, and yeah, master works, so I won't do anything. Unless the connection is broken, we get network partition where something cuts the cable between those two servers, and then master still doesn't see, stops to see the slave, but yeah, I'm master, I don't care. And slave the slave loses the connection to master, so hey, master died, I need to get this IP on me and take the payload for myself. And then we have like two same IPs in the same network, which is bad. And then we have like problems which if you share anything, that's pretty much broken, because when you don't, unless you have like clustered that file systems, if two servers will write to the same shared storage, it will break. As again Pygmy said yesterday, I don't think there is any. I mean, it's almost impossible to have. I think it is impossible to have the database to be fully persistent to for this, and you will lose data. So how I can get that's how can we deal with the split brain problem? Well, health monitoring of server is hard thing. I mean, actually, it's not just, you may say, oh, we ping the server, it responds. That means it's alive, but when it stops responding, it doesn't mean that it's dead. Not necessarily. Someone could just reconfigure firewall to drop ICMP. So let's log it to it. Oh, I can't log on a SSH, but someone could connection, but the actual daemon can still be working and can still be writing to the shared storage. But there's one good way of monitor servers and to make sure that we actually know the state of the server. Because when we kill it, we may presume that it's actually dead. When we cut the power, usually servers dies. So that's how we deal with that problem. It's called fencing. There are a few possible ways to fence. I mean, just not the first one is shut the other node. Is an acronym of shut the other node in the head, which means literally kill the power using, for example, APMI or something like that. But that's not the only way. Sometimes you can just cut off them from the switches. Okay, it will try to write on the shared file, but it doesn't have the connection, so whatever. You can cut off the storage the same way. You can cut off on the storage server that we don't want this server to connect to the shared thing, and just drop the connection. You can pretty much anything that's shared, and that can mess up your data integrity. And that's one of the. I mean, that seems a bit harsh to just kill the node on purpose, but it's actually the only way to ensure that we actually know the state of the server. Much better is active state. I mean, this is better approach. Active gives you. Active is scalable. Active means we have multiple master. I mean, all the servers that we use do the job more or less. Sometimes some may get more, some may get less, but all of them are interchangeable and can deal with all the payload we get. And it's scalable because when we are lacking on resources, we just run another master on 2 or 5, and we can do it automatically. So that's pretty cool. So there are no split brains because, well, there's all the master. I mean, there's no case when slave tries to write on master because, well, there are no slaves. Yeah, we live in perfect society of servers. HA is automatic by design because, again, you kill the node, it dies. I mean, it dies, but all the other nodes are actually taking all the payload. Good example of stateless. I mean, statelessness is actually one of the. I mean, it's not the requirement, but it's much easier to use to make active with statelessness. And HTTP is stateless by design. When you do the request, it gives you the response. So in theory, the same request should produce the same response, no matter which server it lands on. So let's not break it. We can break it. We can, for example, store something in memory, and then if other server gets the request, it won't have the shared memory state. So we'll end up with stateful application, and it will break the HA. So basically, that's the share nothing policy. Don't presume that anything is shared, actually. So memory states that states are shared. There are ways I will to ensure that, but I'll talk about that in a moment. So load balancing, this is a way to make HTTP master, because you get like one. At the end, in your database, you will end up with master slave, because you will have to have one load balancer and the other may be standby, and all the routing goes to all the network traffic goes to the load balancer, and only master works. But there are ways to do that. For example, you can. DNS is active on protocol level. When you ask DNS server for it can return you. It can return you IP, and that can be based on whether or not the client is alive, and DNS itself can be. When you ask the HTTP DHCT, whatever, the daemon that gives you an IP of DNS, you can ask, and it can give you multiple IPs. So the DNS server itself is active, because this is on client side. You just can load balance between them. But what if we want to use, for example, sessions? Yeah, that's how we keep the state of a client using HTTP, for example, because we might want to have, for example, user authentication. Well, there are ways to do that. None of those. I like Redis. It works. Unless it's not, but usually it works. It's not that bad. Cassandra is better in the terms of active design. Redis is still doing that. It's not still. Nothing is perfect in that matter, but Redis tries to do that. MongoDB don't use it. I just posted because technically it can do that, but no. So with that, we can actually keep the state and remain remain stateless in the same time. So if HTTP is so cool, then let's use it more, not only for websites. RESTful APIs are cool. Let's use more of it, because we can use all the statelessness and all the cool thing of HTTP and make it actually API. So we all know that's what REST is, so I won't do that. I won't talk about that. There's also another thing we can use. It's RPC. which gives you a bit more scalability. There was a quite nice talk, I think yesterday or 2 days ago, about RPC. For those who haven't heard that, it's basically we have RabbitMQ, for example, QE server, and we post, hey, sir, do something for me, give me that info, make a virtual machine on this server. Then a client, then the consumer gets the message, oh, okay, I will do that, and post, I've done that. I've done this message, this is payload, and the server that is interested gets the payload. And this way you can activate, you can make the calls, and you don't really care where it lands, which is good, because RabbitMQ gives you another advantage, and that's if one server is, for example, loaded, it won't consume. It won't take another task, so it's also a load balancer. It's by itself. I think this will be a bit shorter. I got too quick with that, but okay. So there are ways how to ensure. I mean, how to increase is SLA. It's not about like HA. I mean, if we, for example, have a website and we still want to increase our SLA, so service level agreement, a little bit more, we can make it. We can cover it with cache layer, for example, and that means, for example, Varnish is a good example. And that means that when we lose our infrastructure, even whole infrastructure besides cache layer, we can still serve some content. It won't be any stateful. It won't have any authorization, but it will be available. So that's good thing. And I won't lie to you if it saves a lot of downtime of many companies, because infrastructure died and just content was served from caching. Also, cache, as it's supposed to be, gives you much performance. The other way is make it virtual. So yeah, I will talk about cloud a little bit, but only a little bit. Why to make it virtual? Virtualization gives you a few nice things. So easy backup. Virtual machines, in general, are just files. I mean, disks or volumes or something, but it's basically a space on disk that you can just copy and that's it. You have completely you have your backup just like copying a file. Easy for provisioning. When you have the hardware server, you have to go to the data center, you have to put it into the rack, and you have connect all the cables and so on, so on, so on. It's much easier here because you just make one call on the terminal and it boots up from the image, and with this network you get and so on, so on. Okay, live migration. That's a little bit more complicated. I'm sure some of you at least knows about that, but that won't give you actual HA. It may give, but it may help you with maintenance. Or there are several cases that can give you better HA, SLA. But what is it? As I said, the virtual machine is a file. Moreover, the memory of virtual machine is a subset of memory of the host. So if it's only a process, actually, or something like that, we can think of it as a process, which takes a part of resources, a little bit of resources and memory. We can just copy this memory, make another VM on the other host, copy the memory state over the network, and when the memory states are equal, we can just move all the traffic to the other node. and it will keep the state without losing anything. I mean, we have done some testing about that, for example, in OpenStack. How fast is that? And it was less than a second. When we move between one of the other on very basic configuration without very fancy storage and so on, it was less than a second. So it's not that bad, and we have kept the state. And there is evacuation. That's actually, I don't know if this word exists outside OpenStack in this meaning, but I use OpenStack nomenclature here. So VM is on shared storage. We have perform live migration, but to perform live migration, the both host has to be alive because we have to copy the state between those two. So what if one isn't alive? Because it's virtual, we may boot the virtual machine on the other node from the same disk. From the VM point of view, it will be just like pushing the reset button. And we can evacuate from the failed host. So one host blows up, something kills power. We get downtime, but then we run evacuate. Let's boot up this virtual machine on the other node, and let it keep all the configuration, all the addresses, so on. And this way, you can actually get more SLA using virtual machine than you can get on the actual host. Yeah. And as I said, I'm a little bit early with that. I'm just speaking too fast, I guess. So let's hope that you have questions. Go on.
Hi. You mentioned the Chaos Monkey at the beginning.
Yeah.
I wonder how in fact it works, and did you run it on your infrastructure? What was your experience?
Personally, I haven't run it. I think it works with OpenStack. Basically, it calls the servers. So when you have virtual machines, for example, it's easier to explain them this way. You can kill machine with one command. But there are ways to automatically kill machines, physical machines as well, like IPMI. I mean, Chaos Monkey is pretty domain specific because it runs on Amazon, so you have all the APIs you can think of. But in general, it's just. I mean, if you'd like to make your own Chaos Monkey, I'd imagine that will be depends on how you configure your own infrastructure. You can, for example, log in on switch and kill the connection. So, I mean, in modern data centers, you can pretty much log in on everything and do pretty much anything from the client machine, including powering off machines like using IPMI. And that's pretty much how it works. There are many different cases that it covers, but...
So you think it's a good idea to have such psycho killer running on your production environment?
Sorry?
Do you think it's a good idea to have such tool running in the production environment? Yeah,
it is actually, because it's hard to... I mean, why I've did that presentation in the first place is because developers tend to think that servers are inevitable. I mean, are impossible, indestructible, and unless you really live in broken by design infrastructure, unless you face the destruction of a server eventual without any warning on your own skin, you won't think. I mean, you can still think about that, it's good, but not everyone will. And by purposely destroying the instances all the time, you are forced to take it into account. You have to think about that all the time, and that makes you actually more robust when actual fail occurs.
Okay, thank you.
What do you mean that in active-active clusters there is no split brain problem? For example, in Cassandra, a cluster can split into two when you have network partition.
Cassandra is not fully active-active. I mean, there is no database that is fully active-active. I mean, 100% active-active. Yes, in Cassandra you can get network partition and you can lose data, but that exactly shows that Cassandra isn't fully active-active. Again, Pygmy yesterday talked about.
Is there any database that is fully active-active, or
no?
What is the system that is fully active-active?
No, there's no database that's fully active-active. Go on.
Actually, there is. If you use React with your DTs, see your DTs, and the structures that you can merge, then with the hinted handoff, even if there is no replica that's assigned to your key, the React will save it on the next available replica, and then when the split ends, you get all the conflicting changes. And you have to merge it yourself. If your data structure is not prepared for that, you have a conflict, you have to drop some data. But if your data structure is prepared for merging, you can merge the data, don't lose anything. So yeah, there is, but there is a high cost attached to that because you have to rethink your data structures completely.
Also, I think it's more like eventual consistency than actual consistency. Yeah.
Yeah, but there is the new React the 2.0 and it's strong consistent and with TRDTs. So it's theoretically possible now.
Okay.
But it wasn't possible like last month or something.
All right. Thank you.
One thing in the topic related to Redis, did you use Redis Sentinels?
No, I haven't used that.
Okay, because the guy who wrote Sentinel have just announced that probably soon he will deploy Redis clusterization. So probably that will happen soon.
Yeah, that's why I've put Redis here. I will believe it when I see it. I put it that way. So hopefully it will.
Yes, we use Redis Sentinel in production, and the switch between master and slaves worked really well. But you cannot rely on it because there are some cases when the sentinels themselves get split brain, and they start switching masters and slave between, and there is a lot of data loss in between. But you are available, so there is no the problem that you have no Redis master and you cannot cache disappears, but there is some data loss when the switch occurs, so it's okay.
I just wanted to add one neat way of doing active-active that we're currently implementing in the project, and that's using Apache Zookeeper to implement a distributed lock, and then we're having multiple instances trying to acquire that lock, and just one of them is running. Thanks. No more questions? Okay, thanks.
Thank you. Oh, one other thing. I was told that I can give you the books, so I will. And I believe that. I mean, don't feel bad about that. That's nothing personal. I just have this one. And so this is actually quite good. I've read it myself, so thank you very much.